Welcome back to my new video. It is the third episode of Cybersecurity Basics 101 playlist. Let's dive into the video. Every device connected to a network has an address. An IP address is like the postal address of your house. It tells other devices where to send the data. It can change depending on the network you are connected to. On the other hand, a MAC address is permanent. It's like the fingerprint of your device burned into the hardware of your network card. While IP addresses can change, a MAC address always stays the same.
My heart rages around like an ocean in my head because there are so many things that
Imagine two entities, the sender and the receiver. In TCP, both sides must establish a connection before any data can be transferred. This process is called the three-way handshake. First, the sender sends a SYN request, a message saying, "Hey, I'm ready to synchronize." The receiver replies with an acknowledgement that it received the request and also sends its own SYN. Finally, the sender acknowledges that message, completing the handshake. Once this three-step exchange is complete, a reliable connection is established between the two devices. Next, when the sender is ready to transmit data, it breaks the data into smaller chunks called packets. Each packet gets a header added to it. In our animation, the yellow part represents the actual data, while the red part is the header. This header contains information like source and destination ports, a sequence number, and a checksum for error detection. The packets are then sent one by one to the receiver. After receiving each packet, the receiver sends back an acknowledgement. Once the sender receives this acknowledgement, it clears that packet from its memory buffer. If a packet gets lost during transmission, the receiver won't send an acknowledgement. The sender waits for a specific amount of time, and if no acknowledgement arrives, it automatically resends the missing packet. Thanks to this system, no data is lost. And once all the packets are received, the TCP protocol ensures that they are arranged in correct order and any errors are corrected before delivering the final data to the application. Once the data transmission is complete, the connection needs to be properly closed. To do this, the sender initiates the termination by sending a FIN request, which signals that it has finished sending data. The receiver responds with an acknowledgement and sends its own FIN request to indicate that it's also ready to close the connection. Finally, the sender acknowledges this second FIN and the connection is officially terminated. Now, UDP or User Datagram Protocol works quite differently. Just like TCP, it splits the data into packets and adds header to each one. But this header is much smaller, containing only the essential information. UDP does not establish any connection before sending data. It simply fires the packet off directly to the destination. No handshake, no acknowledgements. It does not check if the data is received or lost. There is no retransmission. Why? Because UDP prioritizes speed over reliability. It's perfect for situations where speed matters more than accuracy, like live video streaming, online gaming, or voice calls. Here is the comparison between TCP and UDP side by side. You can pause and check out.
Think of ports as doors into your computer. Each port is assigned to a specific service. For example, port 22 is used by SSH for secure remote login, port 80 is used by HTTP for normal websites, and port 443 is used by HTTPS for secure browsing. When data enters or leaves your device, it travels through these ports. Without ports, multiple applications could not communicate over the same network. DNS, or domain name system, works like a phone book of the internet. Instead of remembering long IP addresses, we just type a website name, and DNS translates it into the correct IP. DHCP, or Dynamic Host Configuration Protocol, makes networking easier by automatically giving devices their IP address, gateway, and DNS settings. Without it, we'd have to set everything manually. ARP, or Address Resolution Protocol, acts like a translator inside a local network. It matches an IP address to the correct MAC address, ensuring that data reaches the right device. One of the most basic commands is ping. It checks whether a device or website is reachable and how fast the response is. Traceroute, or traceroute on Windows, shows the exact path data takes across different routers before reaching its destination. Netstat is another powerful command. It displays all active connections and listening ports on your computer, which can even help detect suspicious or hidden connections.
Distance, but I know that it's not reality. If you are echoing around inside these parallel dimensions all alone, know I'll find you in my dreams.
Wireshark is a powerful packet analyzer. It allows us to capture and inspect every packet of data traveling through our network. Network engineers use it to troubleshoot problems, while security professionals use it to detect malicious activity. Nmap, short for Network Mapper, is a scanning tool that helps discover devices, open ports, and services running on a network. For example, it can tell whether a server is running a web service, an SSH service, or something else. It's a favorite tool in cybersecurity, but it should only be used ethically and on networks you're authorized to test.